everybody. In this lesson, we will review some of the basic concepts in geometry and trigonometry that you would require in this class. As a matter of fact, these concepts will repeat themselves over and over and over. Therefore, it is essential that you pay attention, and if you have any questions, please do not hesitate to ask in the discussion forum below this video. If you have two lines, for example, this is line A and another line, this is B. This angle right here is 90 degrees. This angle right here is 90 degrees, which means that this angle right here is 180 degrees. So this is line A and this is line B. We say that A is perpendicular to B. On the other hand, if we have two parallel lines and a line striking through them, this is line 1 and this is line 2. We're going to define a couple of angles here. This angle, let me call this angle A, and this angle, let me call this angle B, are corresponding angles, so they are equal. So A and the B are corresponding angles. And they are equal. A is equal to B. Similarly, this angle, let me call this angle here alpha, or let me just call this angle here C. You see that, look at it carefully. This angle are like the angles under the arms of letter Z. We call these angles C and B. So angle C, or B and C, let me be in order. B and C are alternate angles. And B is equal to C. So alternate angles are equal. So if you look at, for example, this angle and this angle, let me say that this angle here is S and this angle here is T. Angle S and T are actually also equal. They are corresponding angles. But the whole thing that you need to take note is that C plus S is equal to 180 degrees. T plus B is equal to 180 degrees. When two angles sum up to give 180 degrees, we say that they are supplementary. So this, honestly, though it looks very simple, we're going to use this over and over throughout this course that you will encounter. Now, the next thing that I would like for us to take a look at will be triangles. If you have a triangle, this angle here is A, this angle here is B, and this angle here is C. The side opposite to A, I will label it small a. The side opposite to B, I will label it small b. And the side opposite to C, I will label it small c. This is what I call a triangle. A triangle has 3 sides. A rectangle has 4 sides. What you need to take note is that A plus B plus C all sum up to give us 180 degrees. Now, if A is equal to B, which is equal to C, then the sides, the corresponding sides, will also be equal. So this triangle, take note that there is an intrinsic relationship that exists between the angles and the sides. If all the interior angles are equal, then the sides will also be equal. A special triangle that I would like to talk about will be the right angle triangle. This angle here is 90 degrees. We call this the right angle triangle. This angle here is A, so this side here is A. This angle here is B, so this side is B, and let me call this side C. It is worthwhile for you to understand that A plus B plus 90 degrees must be equal to 180 degrees. That means that A plus B will be equal to 90 degrees. Now, if, for example, A is equal to B, this would mean that small a is equal to small b, and A will be equal to 45 degrees, while B will be equal to 45 degrees. And this is a special triangle. So keep that in mind. So we call this the right angle triangle. Now the right angle triangle actually has some very important properties that we need to take note of. We call this, the very first that I will talk about is the Pythagorean theorem. The Pythagorean, or the Pythagoras theorem if you choose to call it that way. Now the Pythagorean theorem basically states that c squared is equal to a squared plus b squared. Understand that c is called the hypotenuse. A is called the adjacent, and B is what we call the opposite. These names will become valid pretty soon. Let's do an example. If we have a right angle triangle, this side is 3, this side is 4, and this side is D. So the question is, find D. Essentially, D squared will be equal to 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16, 16 plus 9, that will give us 25. So this would mean that D is equal to 5. Suppose that you are asked to, you have another triangle. This is 12, this is 13, and this is X. This is a right angle. And we are asked to calculate X. In this case, we know that 13 squared is equal to 12 squared plus X squared. That would mean that X squared is equal to 13 squared minus 12 squared. So X squared, 13 squared is 169, 12 squared is 144, 169 minus 144 will give you 25. This means that x is equal to 5. That would mean that x is equal to 5. Now, let's look at the relationship. Let's draw back our triangle again. This is our right angle triangle. This is the right angle. This is C. This is A, and this is B. This angle here is capital A. This angle there is capital B. So we're going to introduce some basic trigonometric functions. But before we do that, keep in mind that C, the side opposite the right angle, is the hypotenuse. A is simply the opposite, and the B is what we call the adjacent in this case. So the sine of A, it's equal to the opposite divided by the hypotenuse. The cosine of A is equal to the adjacent, which is this angle, the angle adjacent, the side adjacent to B. This is the adjacent divided by the hypotenuse, and the tangent of A will basically be equal to the opposite divided by the adjacent. The simplest way of remembering this is we have the first is sine, opposite divided by the hypotenuse, cosine, adjacent divided by the hypotenuse, tan, opposite divided by the adjacent. This we call SOHCAHTOA. If you can remember SOHCAHTOA, then you will be able to remember this. In my class, you really don't need to memorize this, but it will be nice for you to have a working knowledge of this, because in every test, in every exam, I usually give you a formula sheet. The objective of my class is for you to understand how to use all of these and be able to apply what we have learned. Really, it's lesser in my class for you to memorize stuff. So I strive for understanding more than memorization. So let's do this. Let's look at some spatial triangles. If we have this is 90, this is 45, this is 45. This is only true if this side is equal to this side. So if this is 1, this will be equal to 1, and therefore this will be equal to root 2. Hence, per SOHCAHTOA, the sine of 45 degrees will be equal to opposite, which is 1, divided by hypotenuse, which is root 2. The cosine of 45 degrees is adjacent, which is 1, divided by root 2. And the tan of 45 degrees is opposite over adjacent. This is just going to be equal to 1.